Ian Meng is the director of the Center for Excellence in the Neurosciences and professor of biomedical sciences in the College of Osteopathic Medicine at the University of New England. He received his SCB and PhD in neuroscience at Brown University, did a postdoc in the Department of Neurology at the University of California, San Francisco, came to his senses and joined the University of New England, coming back to New England in 2003. Ian has maintained a continuously funded research program with the aim of understanding trigeminal sensory processing underlying headache and ocular pain and homeostasis. I'll just do a quick pitch. We have a podcast because the whole world has a podcast. It's the Main Science Podcast, and Ian was one of our recent guests, and it was really a great way. You're only going to get 5 minutes of him here, but if you listen to the podcast, you could get 25 minutes of his science and just be captivated the whole time. So I'll throw that out as a thing. Favorite science-themed pop culture item. Bill Nye's a hero. He's always wanted to be a way cool scientist. But Hank Green is pretty great too, and so is Lab Shenanigans from Darian Najin, is that? But he's sticking with Bill Nye the Science Guy. So. Ian's talk is Cool Neurons and the Secretion of Tears Without Pain.
Okay. It's good? Awesome. All right. Thanks, Kate, for the invitation. And pointer? Working. Awesome. So I'm going to talk to you about something that you're looking right through right now. You can't see it. It's the cornea. Surface of the eye. It's there to help protect your eye. And the thing about the cornea is you often don't think about it much. Light goes right through it. It needs to. You need to be able to see things. Light needs to hit the retina in the back of the eye. So it has to go right through the cornea. It's totally transparent. You think it's completely clear. But then, if you actually look at the cornea under a microscope, and here you don't actually have to do any sort of tissue clearing or anything like that because it is transparent, but if you use a genetically modified mouse, then you can actually see the neurons that are innervating the cornea. And these neurons are in red over here. And those neurons, so the cornea is actually the most densely innervated structure in your entire body. And I know what you're thinking, more densely innervated than, yes, more than your fingertip or your lip? Absolutely. So I'd have to say that with your cornea, those neurons are there to protect your eye. They're super sensitive. You can really only feel pain or irritation when anything touches your cornea. And if you look at those nerve endings coming out right out to the surface of the cornea, they all look really similar. But actually, their properties are very, very different. And some of those neurons, a lot of those neurons, are actually there to detect things that might be damaging to your eye. This is actually somebody being sprayed with pepper spray, right? The capsaicin is that active chemical in the pepper spray. And the reason it hurts so much is because it's actually activating a receptor that's on those nerve terminals on the surface of the cornea. And those receptors, back in 1997, were identified as TRPV1, the hot chili pepper capsaicin receptor that are also activated by heat, painful heat, which is why spicy peppers feel hot in your mouth, right? And so this was discovered by David Julius at UCSF, which is actually where I was doing my postdoctoral work at the time. And David Julius in 2021 won the Nobel Prize along with Artem Patapoutian for these discoveries. There was a big competition between these two labs. About 1 day apart, they published a paper identifying another channel, which is a TRPM8 channel, which is responsive to menthol, or what's found in mint, the mint plant, and mild cooling. And so we kind of took those findings and decided to look at the properties of these neurons that are innervating the cornea, and found that some of these neurons are activated by drying of the ocular surface. So we've been studying dry eye in the lab and trying to figure out why does the eye become dry and how might we be able to produce more tears without making things painful. Obviously, some something painful like cutting an onion or hot chili peppers is going to produce a lot of tears, which is great, but it's also going to make a lot of pain too. And so we found a set of neurons that are actually activated when the cornea becomes dry, and then they shut down when the cornea becomes wet. And it turns out that these neurons don't have the TRPV1 capsaicin receptor, they actually have the TRPM8 receptor instead. So they're responsive to menthol, to mild cooling, and to drying. And you might think, why drying? It's because of evaporative cooling. Just like when you sweat and you evaporate, it makes you feel cooler. That's exactly what's going on the surface of your eye at this very moment. And that actually allows you to produce tears without you being consciously perceptive of that occurring. And so we've been looking at some circuitry in the brain where we can take these neurons that are expressing this TRPM8 channel, go through the brain and act out and activate the glands that are producing those tears. And so when we are looking at this circuit, then we can then figure out ways to activate these neurons, produce tears without producing any conscious perception, which may be a good way to develop a treatment for dry eye. And I'm going to leave you with a question. I know you might have some questions for me, which is, this may not be a prompt, or it may be a prompt, but how would artificial tears affect tear production? So people use artificial tears a lot, and you might have to think, is that a good thing or not?
So are there menthol compounds in artificial tears?
So there is something that's on the market in Japan which has a very, very high concentration of menthol in it. And you can watch some YouTube videos of people putting it in their eye, and it doesn't feel very good. Okay. And the reason for that is because they're using such a high concentration of menthol that it's no longer selective for activating that TRPM8 receptor. It's now activating other receptors that are activating those pain neurons. But that is one strategy that people are looking at, is actually putting a very low concentration of menthol in artificial tears to help enhance tear production and keep that circuit activated. There are some issues with that, though, as we're looking at what happens when you have dry eye, especially chronic dry eye. There are some changes in the properties of those neurons that could make things a little bit more complicated. And so.
That's really cool.
Yeah, I was just going to hazard an answer to your question about, are artificial tears beneficial? I would presume that they would reduce the eye's natural production of tears, correct?
Yeah, absolutely. Right. And so you have to then wonder, it's that thing of use it or lose it, right? And that's really true for glands. And so if you're looking at the lacrimal gland, which is producing the tears, if you're constantly shutting down these neurons that are supposed to be activating this circuit by putting those artificial tears in your eye, then you're actually going to be reducing the input into the lacrimal gland, which actually could cause long-term atrophy of the gland itself.
Have you looked into Bell's palsy and how this sort of, works or doesn't work with that?
Oh, yeah. So Bell's palsy, there you're dealing with a trigeminal neuralgia issue, and so which is extremely, extremely painful. With Bell's palsy, you're looking at probably a compression of the trigeminal nerve, its sensory nerve itself, and so it's more of like a nerve damage or neuropathic-like pain. There are some cases now, actually, when people have dry eye, it may feel like their eye is dry, and it may feel like, every time you blink, there's sandpaper on the back of your eyelid. But there's now some hypotheses out there that is a type of neuropathic pain. It's a nerve injury-induced pain because other symptoms might look fine. They might have just a fine tear film, enough tear production, but it's really just the pain that is the issue there.
And part of it is, they prescribe artificial tears because you can't blink.
Yeah, exactly, right, that's for sure.
I'm not sure how that all works or interacts, but, it seems like potentially relevant.
Yeah, absolutely right. Because if you can't blink, you've got to be lubricating the eye. Yeah, I mean we do that even in surgeries. You know, you're going to put lubricant on the eyes if they're open, you know, for a long surgery.
Sorry, I'm back. How, if at all, does this research apply to contact lenses? Are you making minty contact lenses?
Yeah, so that's a fantastic question. Actually, people who wear contact lenses for long periods of time, their corneas become less sensitive. And so even to like mechanical stimulation, so those neurons are becoming less sensitive. And so there is some evidence out there that there's some people who actually could develop dry eye from long-term contact lens use. And so contact lens companies are always looking at ways to help sort of bring the environment into that ocular surface, you know, to make it as you know, normal as possible, even though there's a contact lens covering it to help. And as part of that, they are thinking about ways to coat the inside of that contact lens.
Go ahead.
Is there another? Hi.
Oh, yeah, you go.
I was wondering if there are neurons in the eye socket or around other parts of the eye that respond differently than the ones within your cornea, and how that is affected by the research you're doing here.
Yeah, so absolutely that's true. Not as densely innervated as the cornea, but there are neurons and their properties are different. So some of them will have specialized nerve endings and they'll be, you know, sensitive to light touch, and they're different types of neurons. Not so much what I'm researching, but we do want to look at what's really unique about the corneal neurons compared to the other ones.